We have one more example, and the thing that's different about this one is that I have a radical on both sides. So I have the square root of x plus 2, and then I have a plus 1 outside of the radical, and that's going to be equal to the square root of 3 minus x. We cannot get rid of this 1 from this side without putting it on this side, so we're just going to have to deal with the fact that we don't have an isolated radical. Let's go ahead and use squares to undo square roots. So the square root and the squared cancel on this side, but I can't cancel it on this side because I have a square root here, but I don't have one here. So I'm actually going to have to do the squaring on this side and then see where that takes me. So let's go ahead and expand this. Remember that when you have something squared, that you have to take the thing that is in parentheses and multiply it by the same thing. So let's go ahead and write that out. We are going to have the square root of x plus 2 plus 1 times the square root of x plus 2 and another plus 1 on the outside. Again, that's going to equal 3 minus x. I was able to eliminate the square and the square root on that side. I'm going to use box method again in order to do the multiplication. The multiplication is just going to look a little weird because we have some square roots involved. But it's still the same technique. You put each of your terms in front of a box down the left and then across the top. So this first one is going to be square root of x plus 2 times square root of x plus 2. So I will put square root of x plus 2 in parentheses and square it. Now I have square root of x plus 2 times 1, square root of x plus 2. Next box, same thing. And finally 1 times 1 is 1. So let's go ahead and rewrite this. I have two terms that I can kind of combine. I have two of those, but let's start with my first term, which is the square root of x plus 2 squared. And then I'm going to say plus 2 square root of x plus 2 and then plus 1. Now, on this part right here, I have the square root of something and I am squaring it. I don't have anything outside of the radical, so I can now cancel out the root and the power. And don't forget that all of this is also equal to 3 minus x. Let's go ahead and continue working on this. So I can now write this as x plus 2 x plus 2 in the square root, and then plus 1 is equal to 3 minus x. I see a couple of terms that I can combine. I can combine the 2 and the 1, and so I can rewrite this as x plus 3 plus 2 square root of x plus 2, and then 3 minus x on this side. Notice here that I now only have one radical on one side, so I'm going to continue working to isolate that radical, that square root of x plus 2. In order to do that, I need to move the x and the 3 by subtracting them from both sides. That's going to get rid of these and leave me with 2 times square root of x plus 2. And then on this other side, the 3's cancel as well, and I'm left with negative 2x. Divide both sides by 2 to completely isolate the radical. And so I will have square root of x plus 2 is equal to a negative 1x, or just a negative x. And now I'm ready to undo my square root by squaring. Remember that this is a 2. And whatever I do to one side, I have to do to the other side. The 2's will cancel. Square root of 2 canceled by the second power. And I will be left with just x plus 2. And on this side, I have an x squared. I need to go ahead and move everything to one side and get a 0. I'm going to do Xbox method just like I did before. So I'm going to go ahead and move everything to the right because I like to keep my x squared as positive. This will give me a 0 that I wanted, and then x squared minus x minus 2 here. A times c will be 1 times negative 2, negative 2. And then a negative 1 for my b term. This one you probably don't even need to do a t-chart because negative 2, well, there's only one set of factors that can make that, 1 and 2. The 2 needs to be negative. And so I can write 1 and negative 2 and go ahead and fill in the rest of my x box. X squared, negative 2, and the factors that I just found, a 1x and a negative 2x. GCFs, x, 1, x, and negative 2. Remember, you're looking across each row, so x squared and negative 2x squared gives me x. These really have nothing in common, so I will say 1. X squared and 1x have an x in common. Negative 2x and negative 2 have a negative 2 in common. Remember, we put the negative here because there is a negative in the box we're writing right next to. I can say that 0 is equal to x plus 1 times x minus 2 and solve each of these for x. X plus 1 equals 0 will give me x equals negative 1, and x minus 2 equals 0 will give me x equal to 2. Remember that I have to check these before I can box them as final answers. So I'm going back into my original equation with each of these solutions. So if I try x equal to 2, I'm going to plug 2 in everywhere that I see x in my original equation. So I'm going to say square root of 2 plus 2. I have a plus 1 on the outside, and that's going to be equal to the square root of 3 minus 2. Simplify, square root of 4, a plus 1, and a square root of 1. The square root of 4 is 2. 2 plus 1 equals 1. 3 equals 1. Well, that's not true. So this is going to be an extraneous solution. Let's try negative 1. I'm going to plug a negative 1 in everywhere that I see x in the original equation. Negative 1 plus 2 plus 1 is equal to the square root of 3 minus a negative 1. Be careful there, don't lose a negative sign. This will be square root of 1 plus 1 is equal to 3 minus a negative 1. That's going to give me a positive 1, so this will be 4. 1 plus 1 equals 2, and that is a true statement, so this is an answer.